2.4, multiplying and dividing radicals. Really, we're talking about multiplying and dividing radical expressions here, the difference being an equation has an equal sign and expressions just don't. We're going to practice our sweet algebraic radical skills before we apply them to equations, but don't worry, they're coming. So let's start out with an example that should look familiar. Recall. Expand and simplify. What happens when we say 3x minus 1? No, I'm going to go x plus 2. Well, we can use our we can FOIL it out, or we can use our happy little rainbows, just like Bob Ross suggests. Let's paint happy little rainbows with our algebra. So 3x times x is 3x squared. 3x times 2 is 6x. Now we need to distribute this 1, and don't forget the negative. Psh. Negative 1 times x is minus x. Negative 1 times positive 2 is negative 2. So we're going to simplify that. It's just going to be 3x squared plus 5x minus 2. Bingo, bango, done. What about something that looks like this? 3x minus 1, 3x plus 1. We're going to be coming across this, and what this is it's the conjugate of this. Okay, 3x minus 1 is the conjugate of 3x plus 1. We're using the same terms, 3x and 1, but we're changing the signs between the terms to be positive or negative. This is very helpful, because we'll notice that this one right here, when you multiply two binomials together, you get a trinomial. But what happens in general? What happens when you multiply the conjugates by each other? Happy little rainbows. Bzz, bzz, bzz. Okay, we have 9x squared plus 3x minus 3x minus 1. Heyo, we have 9x squared, 3x minus 3x, just a 0, minus 1. Cool. This is what is also known as something that can, this can be factored like a difference of squares. So what I want us to do now is just to apply it, to apply what we already know to radicals. So example 1. Expand and simplify. So here's A. Ooh. We have 4 root 2 plus 2 root 5 times 3 root 2 minus root 5. Now this gets a little bit trickier, just because there are more things that we're multiplying together. So these happy little rainbows, though I say it kind of in a mocking tone, might be a little bit helpful if we draw it in. And I'm gonna write down something that looks like a complete dog's breakfast, but I think that you guys should be able to follow it no problem. So 4 root 2 times 3 root 2 minus 4 root 2 times root 5. The reason why I put this minus here, it looks like a division, yikes mundo. There we go. The reason why I have a minus sign here is because this is negative root 5. Then we get back to the positives, which is nice, plus 2 root 5 times 3 root 2 minus, because of that negative, minus 2 root 5 times root 5. So here's how I do it. I multiply the coefficients first, and then I multiply what's underneath the radicals. You might be able to do this in far fewer steps than I'm going to show you. More power to you. That means that you have some sweet radical skills. If it takes you a little while, don't worry about it. I would put in the time to practice the long way before we try to cut corners. And so I'm going to show you the long way. 4 times 3 is 12. 2 times 2 is 4. So we have root 4. Minus, there's an imaginary one that's implied right here. So it's 4 root 2 times 5 is 10. Plus 6 root 10 minus 2 root square root of 25. We have some simplification that we can do here. So 12 times 2 minus 4 root 10 plus 6 root 10 minus 2 times square root of 25 is just 5. 24 minus 4 root 10 plus 6 root 10 minus 10. 24 minus 10 is 14 plus negative 4 plus 6 is 2. Negative 4 plus 6, what? Root 10s. Okay? And that's that. On to the next question. Feel free to pause at any time, or feel free to even go back and revisit some questions, because these can be tricky, no doubt. Question B. I was about to say number B. I know that would drive Lucas crazy. 4 root 2 plus 2 root 3, bracket, open bracket, 4 root 2 minus 2 root 3. We have this conjugate thing. Look, the first term is the same, the second term is the same, and then we have opposite signs that are between them. Woohoo! That means that we should have no middle term. That means that we should come out with 2 terms. Now it's a little bit different when there are no x's involved, when there are no letters involved, but yeah, you'll see what I mean. This one right here, because it didn't get rid of that quote-unquote middle term, we had that root 10. But let's see what happens to our radicals in this type of a question. All right, our happy little rainbows. Perfect. So we have 4 root 2 times 4 root 2 minus 4 root 2 times 2 root 3 plus 2 root 3 times 4 root 2 minus 2 root 3 times 2 root 3. Okay, I just want to show you something here. This is the same as this, but this one has a negative in front of it and that one has a positive in front of it. What's so great about this question is I don't have to do any simplification with that, because you have minus something plus that same something, that just zeroes out. So I only need to simplify the 2 end ones. How awesome is that? So the coefficient is 16, root 2 times 2 is 4. We're going to clean that up, don't you worry about a thing. Minus 2 times 2 is 4, 3 times 3 is 9, and that's under the square root, root 9. So 16 times 2 minus 4 times 3 equals 32 minus 12, and we got 20. As I suggested rather strongly in the beginning would happen, we don't have any radical terms here. Okay, we don't have any radical terms because the 2 end ones were just squared. And when you square a radical, it becomes that number that's on the inside. So square root of 2 squared is 2.